We tend to picture the AI revolution taking place in some invisible, weightless cloud. But the reality of generating artificial intelligence takes a massive toll on actual, heavy physical infrastructure. Every server farm powering this revolution operates on the rigid rules of digital computing. Everything is a perfect 1 or a perfect 0. Calculating that absolute, flawless mathematical certainty at a global scale demands an astronomical amount of electricity. The computing demands of modern neural networks are doubling every few months. Supplying the power for all that perfect precision is pushing the global power grid to the edge of failure. To keep the lights on, hardware engineers are realizing they have to abandon digital perfection entirely. They are pulling a blueprint from a 2,000-year-old technology. The hardware flaw that is draining the world's power grids provides a direct window into why so many of us feel exhausted by the demands of modern life.
Whether you are cooling a warehouse of silicon chips or managing your own biological energy, true sustainability requires letting go of the illusion of absolute certainty. Almost every computer you have ever used traces its lineage back to a design formalized in the 1940s by mathematician John von Neumann. He built a system where the memory storage and the processing unit are physically separated. To perform a calculation, information has to be shuttled back and forth across the narrow gap between these two components. The actual math is incredibly cheap. It is the friction of moving that data back and forth over and over that eats up the vast majority of the time and electricity. Engineers call this the von Neumann bottleneck. Shrinking transistors or stacking more processing cores together does not eliminate this physical gap. It simply creates a faster, hotter traffic jam. In Texas, a startup called Mythic AI is attacking the hardware directly. They are manufacturing a new generation of microchips that skip digital computing entirely. Instead of breaking information down into rigid binary code, analog systems calculate using continuous physical properties. These chips bypass the bottleneck by performing matrix multiplication directly inside the memory itself. By shooting varying voltages through a physical grid of resistors, the answer is calculated instantly. There is no shuttling data back and forth. Using physical voltage to do math means dealing with real-world noise. The calculation is incredibly fast and highly energy efficient, but it is mathematically imperfect. Modern neural networks do perfectly fine with flawless precision. When an AI attempts to recognize a complex pattern, minor variations are easily absorbed. A strong approximation works. By letting go of absolute certainty and accepting a roughly 96% accuracy rate, the analog system circumvents the bottleneck altogether. The result is a staggering drop in physical energy consumption. This hardware shift reveals a mismatch in our own psychology. The human brain is an evolved biological neural network, an integrated, analog system that processes information in a state of constant flux. Yet we increasingly attempt to run this organic hardware as if it were a rigid digital CPU. We treat our daily tasks as binary problems, exhausting ourselves of a search for absolute true or false certainty in every decision and output. This forced precision is where the energy drain happens. We aren't fighting a hardware bottleneck. We are fighting our own biology by wasting immense cognitive energy on over-verification and the constant shuttling of anxieties. Forcing a fluid neural network to operate with the uncompromising rigidity of a digital processor is a direct path to systemic energy failure. The most efficient silicon chips succeed by leaning into fuzzy logic. They accept a slight margin of error, that 96% accuracy, to gain massive speed and efficiency. We can apply that same efficiency to our own work. If the most advanced neural networks don't require 100% precision to recognize a pattern or solve a problem, then neither do we. Reclaiming our energy means recognizing that good enough is often the most intelligent outcome possible. True intelligence, whether in a microchip or a human mind, isn't about eliminating every ounce of noise. It's about finding the signal within the highly efficient, fuzzy reality of an analog existence.